And yeah, I'm an engineer by electrical
Okay.
engineer.
So maybe I wasn't asking the right person these questions, maybe, or no?
Yeah. There were some actual astronomers and astrophysicists here.
They will be here in a few minutes. They were
Yes.
just doing some interviews for Fox TV.
Oh, really? So every October, the largest balloon event in the world, called the Balloon Fiesta, is held here in New Mexico. People from all across the world come to this event. It is said to be the most photographed event in the world. NASA likes to come to manipulate the masses with their heavily influenced fake explorations and fully accepted pseudoscience. This year, they came for the 2023 annular eclipse. So I decided I would go have a chat with them and ask them about their heliocentric model. I really don't think that they were expecting someone like me to walk up in there with the amount of ammunition that I have. Yeah. With you? I was actually just... So, do you mind if I ask one more?
Absolutely.
Okay, cool. This is fun for me, I'm sorry. I've heard different theories about this one, and none of them really stuck with me. We have the troposphere, stratosphere, mesosphere, thermosphere, exosphere, right? And it's goes to high to low entropy air molecules, right? What's containing the air pressure?
Well, gravity is holding the atmosphere onto the Earth.
Well, gravity's not a solid container. You have to have a solid container to actually have it contained.
No.
That's actually the second law of thermodynamics.
No, but if you have enough, if the gravity is strong enough to prevent the gas particles from achieving escape velocity, it'll stay there. If the atmosphere gets too hot and the gas molecules move too fast, they will boil off.
Okay.
That's what happened early in the solar system. That's why something like the Earth doesn't have a lot of hydrogen or helium in the atmosphere. That all boiled away. Because they're very light elements. When you heat them, they move very, very quickly and they disappear from the planet. But heavier molecules like oxygen, nitrogen, methane, there's enough gravity in the atmosphere of layers to keep it there.
Okay, cool. Well, in a controlled environment, yet again, an observable, repeatable, testable experiment, air pressure has to be contained by a solid container. Unless you can prove to me that gravity can contain air pressure here in a controlled environment.
But I think Earth, it's not a contained environment. You do have escape.
I mean, there is.
Well, that means the atmosphere would escape then. The air would escape.
Again,
You can't have a solid, you can't have a negative pressure system against a positive pressure system without causing an equilibrium to opposing forces, causing a balance in nature, or having a solid barrier in between the two. In real life, observable reality, that doesn't happen.
No, that's not true. If a strong gravitational force holding onto the atmosphere, if the particles don't achieve escape velocity, they're not going to leave the atmosphere.
Can you prove it?
Listen, this is getting ridiculous. I would
Thanks,
like to
guys.
stop the conversation.
Okay, cool. No worries.
Yes, we can prove it. I'm not going to do it.
So you can't do it in a controlled
Sitting
environment here
here.
on Earth, though.
What was that?
You can't do it in a controlled environment here on Earth.
The Earth still has an atmosphere after
I mean, we
5
are.
billion
Yeah,
years.
we're literally doing it right now by being able to breathe.
Or we're being contained by something.
Well, you also have to remember that the Earth's atmosphere gets replenished by volcanoes and things as well, although that wouldn't be enough to keep this breathable atmosphere around us.
Exactly.
But it does add water
So
vapor.
you're a firmament believer?
I am.
I mean, why?
Well, one, air pressure has to be contained. Every time I take my Nikon P1000 or P900 to zoom into, say, Venus, I see water going through it.
Are
You're not talking the same. It's not the same thing as looking at an atmosphere hanging on to a sphere of matter. Any experiment you do on Earth is not going to have the mass of the Earth in your little experimental lab.
So, in other words, a lot of the heliocentric model can't be proven on Earth then.